Okay, we're going to look at Pythagoras' theorem today. Now, Pythagoras was a Greek philosopher and mathematician. He was born in 570 BC and he died in 495 BC. He came up with a theorem that we know as Pythagoras' theorem, which is used a lot today. Let's have a look at what that is. So Pythagoras said, in a right-angled triangle, so there we go, there's a right-angled triangle, the square on the hypotenuse. Okay, so first of all, the hypotenuse then is this side here. It's the longest side of the triangle, and it's always the one opposite the right angle. So that's the hypotenuse. Back to Pythagoras' theorem. The square on the hypotenuse, there's the square, let me stick it on top of this hypotenuse, is equal to the sum of the squares on the other two sides. So there we go, there's another square on that side and another square on that side. So what he means by that is that this area of this green square is the same as the area of this square and this square added together. Now we can turn that into some algebra. So if we give each side on the triangle a name, so this is side A, this is side B, and this is side C, then we can work out what the area of each of these squares would be in terms of A, B and C. So this length here is A, and because it's a square we know this length here is also A, so the area of that square is A squared. Look at side B, this will also be a length B down here because we know it's a square and all of the sides on a square have the same length, so the area for this square is B squared. And then there's side C, and the square sitting on top of side C has got an area of C squared. So if we turn that into a formula now, what we're saying is this: C squared, this area, is equal to the sum of the other two areas. So it's equal to A squared plus B squared. Now don't worry if that's baffling at this stage. We're going to look at how you can use that to solve some problems next. Okay, so there's another bust of Pythagoras. There's his theorem. In a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides, or if you like, C squared equals A squared plus B squared. And there's our diagram from our PowerPoint just a minute ago. So there's the triangle, hypotenuse marked, and the sides marked. I'm going to come back and look at this in a second. So this is a typical kind of question that you might get asked. Okay, there's a right angled triangle, and I'm going to give you the fact that this height here of the triangle is 3 cm, and the base along here is 4 cm, and you've got to try and find the length of this side that we're going to call x. Okay, so this is how we get started. We always start Pythagoras theorem questions the same way. Write out Pythagoras theorem, the formula. So C squared equals A squared plus B squared. It's the same every time, and if you write it out every time you'll get the hang of remembering it. Then we're going to compare what we've got over here. So this C in our diagram corresponds to the x in this question. So let's make our C an x. Okay, and then our A will be 3. So that's going to be 3 squared, and our B here at the bottom will be 4 there, so that's going to be 4 squared. From now on in, all we've got to do is follow what the maths tells us to do, follow the equations, a bit like doing a recipe. So let's have a look. X squared, we can't do anything with that just at the minute because that's what we're trying to find out. We're trying to find x, but we know that 3 squared is 3 times 3, and 3 times 3 is 9. 4 squared, 4 times 4 is 16. Okay, now look, the formula telling us add those numbers together, so let's do that next. X squared is 9 add 16, and 9 add 16 is 25. So we're almost there, we've almost figured out what x should be. Some number, when you square it, makes 25. That's the x we're trying to find. We can get it on a calculator by taking the square root of 25. You can do that on your calculator, the square root button. You probably know what the answer is already if you've figured it out. X is 5, and there we go, there's our answer. Okay, so nice, clear working out, nice logical flow. Let's try a slightly more difficult question. Okay, well, first of all, I flipped the triangle over so that it's looking slightly different, and I'm going to tell you that this side along here is 10, this side along here is 7, and there's X. Okay, so that's what we're trying to find out. Okay, so let's have a go. How do we start these problems again? We always start with Pythagoras' theorem. C squared equals A squared plus B squared. Okay, so don't forget, C is the hypotenuse, the longest side, the one opposite the right angle. Okay, so that's going to be X in this case. And A squared and B squared are just the other two sides. It doesn't matter too much which way you pick for these. So you could say A is 10, that would be fine, in which case we'll have 10 squared there, and you could say B is 7, which means we've got 7 squared here. If you did it the other way around, it would still work out absolutely fine, no problems. Okay, so keep going. X squared equals 10 squared, 10 times 10 is 100, plus 7 squared, 7 times 7 is 49. So X squared then must be 149, and that means we can find X if we take the square root of 149. So if we do that in a calculator, X equals 12.2065556 on my calculator. Now we obviously don't need to write all of this decimal number down in our final answer, so we're going to round our answers to 3 significant figures. So we'll always be looking to see 1, 2, 3, and then look at the next number along to see what that is. X equals 12.2 to 3 significant figures. So if you get a long decimal answer, write the whole decimal out and then do the rounding to 3 significant figures, or whatever the question asks. Okay, that's that question done.